Okay guys, good to see you again. Before we start, let me give you 3 good news. Number 1, this is the very last recording for the unit. Number 2, it will be a shorter recording. Number 3, you do not need your calculator. Okay, so let's go ahead and start. Objectives. You will be able to explain what is meant by the mechanisms of a reaction using the terms elementary steps, rate determining steps, and intermediate. You should be able to derive the rate law for a reaction that has a rate determining step given the elementary steps and their relative speeds. Homework is quest kinetic mechanisms. Okay, quest kinetic mechanisms. So make sure you complete all your quests because you already have your free responses ready to go, and there is a test on your way coming up. Reaction mechanisms. What is it? Reaction mechanism. Show the relationship between the reaction pathway and the rate law. Even if you don't understand now, be patient. We will explain it. It is a series of elementary steps that must satisfy two requirements. Here are the requirements. The sum of the elementary steps must give the overall balanced chemical equation, and the mechanisms must agree with the experimentally determined rate law. It may be very confusing up to now. Don't worry, it's coming. What are intermediates? Intermediates are the species that participate in elementary steps of a reaction but are not involved in the overall reaction. You need to know what are molecularity. I'm going over those terms with you first, and then I will explain it when we start doing some practice. I'm just defining those terms. And I see there is a typo here. Species that participate. Missing an A here. Alright. Molecularity. The number of molecules that participate in an atomic rearrangement. Okay. Unimolecular. There is only one molecule that is involved as a reactant. That means the only thing that can happen to it, if you have a reactant that will decompose, there is only one reactant involved. What is bimolecular? Bimolecular means you have the collisions between two reactant molecules. Collision between two. And then thermolecular, which is very, very rare. Having 3 molecules colliding simultaneously. Okay, collision between 3. This really does not happen, or higher is even worse. You can have one reactant that will decompose. You can have 2 molecules colliding at the same time, but having 3 molecules colliding at the same time, it is very, very rare. So on quest, when they ask you if which one will you have, you can definitely choose the unimolecular and the bimolecular. Let me start explaining exactly what we mean. Reaction mechanisms. It means exactly the map that will show you from the reactant to the product. Let me give you an example. In biology, you have learned that photosynthesis, the balanced chemical equation is 6 carbon dioxide molecules react with 6 water molecules with energy from the sunlight to produce 1 molecule of glucose and 6 molecules of oxygen. But you will never have 6 molecules colliding at the same time with 6 water molecules to produce glucose. It doesn't happen. This is just when you start, you will start with 6 carbon dioxide, 6 water. At the very end, you will have 1 glucose molecules and 6 water molecules, 6 oxygen. This is the overall reaction. This happens in several steps. So reaction mechanism is just showing you the different steps in between. But you cannot even prove that. This is just a proposition. It is an educated guess. Alright? So we have to use the reaction rate that is determined by experiment to explain, to choose that, to see if the mechanism is valid. Okay, made up of several intermediate steps, though each step is called elementary. Another typo here, elementary, no C. Alright, so here's an example. So I hope you understand exactly what is elementary. Elementary is just 1 step. The overall reaction can have several steps. So elementary is 1 step. So if you have only 1 molecule that will decompose, it is unimolecular. You have 2 molecules colliding together, it is bimolecular, and we said termolecular is very, very rare. Now this is hydrogen peroxide that will produce water and oxygen. For this reaction to go faster, you use a catalyst. You use, let's say you use potassium iodide as a catalyst. That iodide, this is a proposed mechanism. So this is your balance equation. This is a proposed mechanism. This is slow step. You have hydrogen peroxide plus the catalyst give you water and an intermediate. I need for you to pay attention right now because those are typical questions in AP. This is an intermediate. This is not stable. Okay, it is called a radical. So if you go to the next step, this is a fast test, a step. This is another molecule of hydrogen peroxide that will react with that unstable intermediate to produce water, oxygen, and this is the catalyst. So what is a catalyst? A catalyst will enter the reaction. It will always be a reactant on the first step, and it will always be a product on the very last step. In AP questions, in free responses on the test, they will ask you the difference between a catalyst and an intermediate. So I'm telling you the difference right now. A catalyst will always enter the reaction, and the catalyst will get out on the last step without being changed. They will ask you what is an intermediate. As you see here, an intermediate is formed on one step, is used up on the next step. So the intermediate is not part of the balance equation. It is not stable. It will be formed and quickly be used on the next step. This is an intermediate. So in the overall reaction, you don't have the catalyst, you don't have the intermediate. The catalyst is used and come out. The intermediate is formed and being used, which is different than a spectator. A spectator does not participate at all in the reaction. The spectator is just there. So make sure you know the difference between an intermediate, a spectator, and a catalyst. The next equation, you add those 2 steps together to give you the 2 hydrogen peroxide to produce 2 water molecules and 1 oxygen. So what you will be doing in your AP problems, okay, because there is an action here, let me wait after I will show you. The iodide, which is the catalyst used in reaction, comes out. This is a catalyst. The intermediate, this is the intermediate, will be formed and then used up. This is a table that shows you exactly how to write the weight law for an elementary step. If you have only one molecule or one element, we said it is unimolecular, and then this is the weight law. For a balanced chemical equation, we told you the coefficients do not tell you the order of the reactant because the order is determined by experiment. But for an elementary step, the coefficient, yes, tell you the order of the reaction. Let me repeat. In a balanced chemical equation, the coefficients are not the order. The orders are determined by experiment. But for an elementary step, yes, the coefficient tell you the order. It is elementary. For example, here you have two molecules or two elements. This is bimolecular. You can use this to write down the weight law. So it is first order in A, first order in B. This is, again, you have two molecules here, even if they are the same kind. This is bimolecular. You can use this to write the weight law. It is second order. And then you have here again, this is third molecular. You use the equation, the elementary step, to write down your reaction rate. Okay, so those are typical AP questions I'm practicing right now. So I would advise you to pay attention right now. This is a balanced equation. They are telling you by experiment the weight law was determined to be this. They give you the weight law. Because molecular processes are very rare, this weight law suggests a two-step mechanism. They are telling you that this reaction does not happen in one step. Show that the following mechanism for the above equation produces a weight law consistent with the experimentally observed one. This is the way they will always ask you that AP question. This is the balance equation. This is the weight law determined by experiment. They are proposing a reaction mechanism, and they ask you, is that a valid mechanism for that weight law? This is what you do. Listen carefully. What I'm going to show now is this is not the way you have it in the textbook. It is different. The textbook gives you a much longer way to solve it. So what you should do, shorter way, the first thing you do, I need for you to, there are two conditions for this mechanism to be valid. When you add up the different steps, it should give you the balance equation. Okay, so always add up the balance, the different steps, and see if you have the balance equation. Before we do that, why don't we cancel the intermediate? If there is any intermediate, this is an intermediate. Okay, I cross it out because it is here, it is formed here, and it is used up in the next step. Let's see if there is anything we need to cross out. Just like you did in Hess's law. You cross out any catalyst, you cross out any intermediate, and then I add them up. So I have NO and NO give me 2NO plus this is Br2. Yield, this is 2NOBr. 2NOBr. And I check my balance equation to see 2NO plus Br2 yield 2NOBr. The first condition is fulfilled. So you need both conditions to be right. Okay, both conditions. So this is one. Here's the second condition. That's the one you don't know yet. Listen carefully. The second condition is the rate for the mechanism. The rate should be the same as the weight law they gave you that was determined by experiment. So this is the way you will determine the weight law, which is different from your textbook. I need for you to find the slow step and then draw a line under the slow step. Let me define one term that I said at the beginning. I will repeat it. The slow step is called the rate determining step. The reaction rate is determined by the slow step. When you get up in the morning, you cannot get out of that house, okay, as faster than the slower person. Okay, so the slower person is the one that determines how fast you can get out of this house. If you play sport, okay, the faster the team cannot be faster than the slower player. The team is not as good as the one that is the least productive. Okay, in the morning, again, this is a very good example. So the slow step is what determines the weight loss for that reaction. So now I will draw a line under the slow step. Under the slow step. If I had a third step, a fourth step, I would forget about the one that come after. I stop at the slow step. I'm going to write a weight law for each step from the beginning up to the slow step. So a weight law for the first one. Let me write down R. Weight 1 for the first step. Weight 1 equal, I will call it K1, weight constant for the first step, times the reactant, which is NO times BO2. This is the first one. For the second step, I write down weight 2 equal K2 times the concentration of the reactant from the second step. But remember, I cross out that intermediate. It's gone. So I write down NO. And I add up the weight. I add up both weights to give me the overall weight of the reaction. So the weight of the reaction is, okay, K times K give you K, your constant, times NO times NO give you NO to the second power, and then time BO2. After I check the weight law for the different steps, I compare it to the given weight law. This is the given weight law. They are the same. So I said that this mechanism is valid. Let's do one more. We said here, let's go to the next page. The typical question. They say here, nitrogen oxide is reduced by hydrogen to give water and nitrogen. And then here is the balance equation. They give you the balance equation. And one possible mechanism to account for this reaction is they give you the mechanism. They give you different steps. Alright? The problem here, they don't tell you which one is slow, which one is fast. They don't tell you. They say, what is the... Okay, so I don't really need it. Because they ask me, what is the molecularity? Get you to that term. What is the molecularity of each of the three steps? Show that the sum of the three elementary steps is the net reaction. Okay, molecularity, remember the term unimolecular, bimolecular, and termolecular. This first step is bimolecular. You have two molecules colliding together. This one is bimolecular. You have two of them colliding. This one is bi. So you just count how many molecules are colliding with each other in each step. They are all bimolecular. But they ask you to show that the sum of these elementary steps is the net reaction. So let me draw a line. I'm adding the reactions. Let me find the intermediate. Let's see. This is an intermediate because it was formed here and it was used up in the next step. Let's see if there is any other intermediate. I think this one is. This is N2O formed in the next step 2 and used up in step 3. Okay, and then all I have to do is add up what I have left, just like Hess's law. I have 2NO plus 2H2 yield N2 plus 2H2O. And I compare it with my balance equation. It is the same. So it satisfies one of the conditions to be a valid mechanism. Okay, let's do one more. The balance equation for the reaction of the gases nitrogen dioxide and fluorine is, this is your balance equation. This is the experimentally determined weight law. By experiment, this is determined. A suggested mechanism for the reaction is, they tell you this is the mechanism we suggest, that exactly what happened step by step to get that weight law. Is this an acceptable mechanism That is, does it satisfy the two requirements justified? The two requirements are, I'm adding those steps to see if it gives me the overall reaction. Okay? Add them up. I'm checking to see if there is any intermediate to cross them out first. This is an intermediate. It is formed in the first step and used up in the second one. I don't see any other intermediate, so I add them up. Give me 2NO2 plus F2 yield 2NO2F. This is just one condition. So I need 2NO2 plus 2NO2F. Okay, it is yield. Okay, thank you. The next condition is I'm going to see if the rate law for the elementary step will give me the rate for the overall reaction. Like I said, if you check your book, you will see a long way. All we have to do, I'm showing you a short way. All you have to do, draw a line under the slow step. Draw a line. And then do not pass that slow step to write your rate law. Do not pass it. It's like you're going on the highway. You have easy pass, and you have the toll. So when you stop at the toll road, the people who stop at the toll, they are the one who will determine the rate you can go on that highway. It doesn't matter how fast you want to go. You cannot go faster than them. You cannot go over them. It's like going to Costco on Friday afternoon. It doesn't matter how fast or how if you are in a hurry. There are people in front of you that I have no idea what they are doing there. So you cannot go faster. They are right in front of you. Okay, cannot go faster. Okay, if they are trying each tester there, you cannot go faster than them. All right. So we stop right here. This is our rate determining step, the slow step, and we write our rate with that. We write down rate equal the rate constant time the concentration of the reactants NO2 times F2. And then I check the rate, the given rate. Yes, it satisfies both of them, the stoichiometry and the rate law. Let me see if there is one page. Oh. This is the last one. I promise I cannot go anywhere. It says 63. All right, this is step 1. This is step 2. This is step 3. Okay, nitramide decomposes slowly in aqueous solution. This decomposition is believed to occur according to the reaction mechanism above. Determine the rate law. Oh, they did not give you the rate law. They asked you to determine the rate law for the decomposition of nitramide that is consistent with this mechanism. So I don't have really anything to compare. All I have to do is, they don't even ask me if it's a valid mechanism. So all I have to do, I'm going to draw a line over. Why don't I cross out my spectators, my intermediate first? I see N2, N2H, N2HNO2. This is not an intermediate. Yes, it is. Yes, it is. This is an intermediate. This is an intermediate. Wow. 2 intermediate. This is 1 and this is 1. Here's another one. Another one. Okay. So the only thing I really have left is my reactant. Rate equal. This is my rate constant times N2 H2 O2. Okay, so this is the rate law. Alright, so we are done with the kinetics. So I need for you to make sure you start working on your free responses and get ready for your tests after next week. Enjoy your day. Bye.